This is the Amiga 1000, the very first of a revolutionary new platform. This particular example has been put through the ringer at the hands of the shipping company. It's completely dead, but I think this pioneering system deserves a second lease on life. I'm Matt D'Amico, and welcome to episode 89 of Retro Bits. Launched in the summer of 1985, the Commodore Amiga ushered in a new era of personal computers, raising the bar with its best-in-class graphics, sound, and multitasking capabilities. All this power came at a price, though. $1,300 got you in the door with a base configuration of 256K and no monitor. Put in context, that was almost 10 times the price of a Commodore 64 at this point in time. To differentiate the new product, the Amiga would be sold exclusively by computer retailers instead of in department and toy stores, like the 64 and other home computer and game systems. Codenamed Lorraine, the new system was developed by former Atari employees who had set out on their own after the Warner Communications acquisition. A prototype running the now infamous Boing Ball demo was shown at CES in January of 1984, but the new company was dangerously close to running out of money. After securing a sketchy loan from their former employer, the company would end up being purchased by a post-Trammell Commodore International for $24 million. Jack, now leading Atari Corporation, would be forced to develop the competing ST computer line instead. As an important piece of history, the A1000 has been on my radar for some time when I stumbled across this auction on eBay. The title and images depicted a machine in a sad state of affairs. Being a sucker for hard luck cases, I took a deeper look. As the story goes, the Amiga was previously sold on eBay but was heavily damaged during shipping. Extensive trauma was visible to the front of the system and it wouldn't power on or boot up. Excellent YouTube potential, thought the overly optimistic bidder, unaware of what he was getting himself into. In retrospect, maybe the $235 price tag wasn't that great of a deal. This clean, working machine recently sold for not that much more, and included the original keyboard and mouse, which were missing from my unit. I could have shopped around more, but hey, what fun would it be to buy something that just works, right? And here we are, the eBay Amiga 1000, the original Amiga, the OG. And yeah, we can already tell right away that this thing has seen better days. The plastic is in rough shape. And we know from the eBay ad that this machine will not boot. So let's go around the system, we'll have a look at the damage, and also take a look at some of the features on the Amiga 1000. Here above the power LED, we have the Amiga, not Amiga 1000. This was just the Amiga before it was known as the A1000. And we've got the rainbow check mark here instead of the Commodore Chicken Lips logo or the A symbol that was used on later Amigas. Front and center, we have the RAM expansion cover, and this thing has probably taken the most damage of all the parts. We can see we've got a big piece missing here and a crack that runs through it. The bottom is almost completely separated and the top clip is broken off as well. Fortunately, the seller on eBay had found this one broken piece and he included it, so we may be able to glue this all back together. Now, 3D printed parts are available, but I hesitate to do that because getting a color match between the left, right side and the center will be almost impossible with a 3D printed part. So I would like to try and restore the original part as much as I can. In the center here, we have the 512K RAM expansion. This is 256K that supplements the onboard 256K to bring the machine up to a total of 512, and this looks to be relatively intact. I also don't see any problems with the card slot here that the RAM expansion attaches to. That looks fine. On the right-hand side, we have the integrated 3.5-inch drive. It is missing the eject button, so either it broke off inside the case and we'll find it there, or it's missing entirely, in which case I'll have to 3D print a replacement. There's also a hairline fracture that goes from the drive all the way to the edge of the plastic, all the way through, so we'll have to repair that. And one of the signature features of the Amiga 1000 is the integrated keyboard garage. Of course, this did not come with its keyboard or mouse, and finding an original at a reasonable price is going to be next to impossible, so we'll explore some other options for that as well. Here on the right-hand side, we have the mouse and joystick connectors, which are pretty standard for all Amigas. And then we have the bus expansion slot here, and the edge connector looks to be in good shape. I don't see any damage, but it is missing the cover, so perhaps I can 3D print one of those as well. Here on the back, we have the standard assortment of I/O ports, starting with the keyboard. What's unusual about this is it's an RJ11 phone jack style connector instead of the round DIN plugs found on the later big box Amigas. Next to that, we have a standard parallel port, external disk drive connector, and a DB25 serial port for your modem. Moving on, we've got the right and left audio jacks and the 23-pin RGB connector that's standard on all Amigas. What's not standard is this round DIN connector, which is designed to connect to an RF modulator. Now, I find it funny that this machine, which was designed as a business and graphics workstation and uses an RGB display natively, still has support for the crappy old RF televisions. And it also has built-in composite video, no external adapter needed. And finally, we have an integrated power supply with a port for a standard 3-prong power cord. All in all, the back of the machine looks fine except for this one piece of broken plastic here, but it's just aesthetic and it doesn't look like it's going to cause us any problems. Here on the left-hand side of the machine, the only notable feature is the power switch. There is a little piece of broken plastic in there, maybe we can glue that back together, and the on-off switch doesn't really click into the on position. It does click off, but it seems kind of muddy on the on position, so maybe the switch needs some cleaning. Well, maybe it just needed a little workout. Okay, the switch seems fine. Moving on. The only label found anywhere on the machine is here on the bottom, and it just says Amiga, FCC ID and serial number, made in Japan, model number 1000. There's no submodel. There's not even a build date on this sticker. It does say UL pending, so it hasn't even been through certification yet. I'm guessing this is a relatively early model, but it's really hard to tell because, again, there is no build date. So I was poking around at the machine and I noticed something. There should be 2 screws holding this front bezel in place, but those screws seem to be missing, so I should just be able to remove this thing entirely. Yep, look at that. The screws should be here and here, but they're not there at all. And in fact, the tabs that the screws go into are pretty much either destroyed or broken. So this thing is in pretty rough shape. You can see there's some damaged plastic right there. And here's that hairline crack I was talking about in the side as well. I would like to try and save this piece because there are no aftermarket replacements available. You will not be able to find one on the used market, and there are no 3D printed parts available right now either. So trying to restore this one to its former glory is probably the best option at the moment. Now to open the machine up, it looks like there are 5 screws, but this one is missing entirely, so let's get those 4 out and see if I can get the top off. So when I flipped the machine over, it made a pretty good rattle. There's definitely something floating around in there, and a 5th screw fell out of the inside of the machine. So I guess I've got that 5th screw, or some screw. Let's see if the top comes off. Aha, there we go. Of course, it wouldn't be an Amiga 1000 video if we didn't take a look at the inside cover, where we'll find all of the names of the people who worked on the project. Right up here, of course, we have Jay Miner's name with the paw print of his dog and everyone else who worked on the project. And right there, we've got the model 327002-01 Rev A. So I'm gonna look that up and see if that will tell me anything about this particular system. But there we go. All of the people who worked on the Amiga 1000. The first thing I want to do is visually inspect the system and see if there's any obvious signs of damage. Now, it still had some stuff rattling around inside after I took the top cover off, so I shook it out, and these 2 broken standoffs that came from the top cover fell out. And if you look here, they've got these little metal caps on the top, so it's possible that these were shorting something out and may have damaged something on the board, but we won't know till we power it up. Unfortunately, the eject button was not rattling around inside the case, so it looks like that's missing entirely. Anyway, let's take a look and see if there's anything obviously wrong with the system. Now, for those of you who aren't familiar with the Amiga 1000, and that includes me, this is the first one I've ever owned or worked on, this riser board here is called the Writable Control Store, or WCS. And on these early Amiga 1000s, the firmware wasn't done in time for the machine to go to market, so what they did is they have a small 8K ROM on the system, which allows you to bootstrap from disk the Kickstart ROM onto this daughter board here. This has 256K of write-protected RAM, which you load Kickstart onto, and then you can boot the workbench from there. So what we need to do is examine for any cracked solder joints or anything broken on the board, because we know the machine took an impact. So we've got 256K of RAM here, we have 256K of chip RAM here, and any other number of components could be broken. So let's start by disassembling this thing and taking a look. Now, before we do that, I noticed here that the power supply connector has been spliced. So clearly someone has gone in and replaced the internals or reworked the power supply and then spliced it into the original connector. Now, it looks like a good job here, so I'm not too worried about these connections, but I do want to test the voltages coming out of the power supply and make sure that they're good before we do anything else. So let me grab my multimeter and we'll test out the power supply. Before we test the power supply, I popped the top and just did a visual inspection. We have a bunch of capacitors, but I don't see any leaking or bulging. Nothing is obviously scorched or damaged. There is a fuse down there, so let me grab my multimeter and just test continuity on the fuse. Okay, we're good there. So what I'm going to do is I'm going to power up the PSU and then I'm going to test the voltages coming out. All right, according to the service manual, the purple wire is -5 volts, the orange wire is +12, black is ground, red is +5, and then the gray is a 60 hertz signal, so I'll grab my scope and we'll test that as well. One thing that's interesting is I plugged the power in, but the switch is still off, yet the fan is running. So I don't know if this thing has been wired to have the fan running all the time, or if the power switch is broken and it's stuck in an always on state. I guess I can test that as well. But let me grab the meter and we'll test this out. Okay, let me flip the switch. Oh, I don't need to flip the switch. We've already got -4.97 volts there with the switch in the off position. Let me flip it to the on position. Okay, so clearly the switch doesn't do anything and it's stuck in an on position. All right, interesting. Let's test the -12 volts or +12 volts. Okay, 12.05, great. We have good 12 volts. Let's test the two 5-volt rails here. 5.11 and 5.11. Great. So we have good voltage regulation coming out of the power supply, but the on-off switch is clearly knackered. And just for good measure, I tested the on-off switch and there is indeed continuity through it regardless of what position it's in. I also tested for resistance. There's effectively 0 ohms through the switch, so it's not causing any problems, but it should be replaced in order to have a working on-off switch here. Now I apologize, you might not be able to see this real well because the screen is so small, but I tested it here and we have a solid 60 hertz frequency coming out of this gray wire here. So looks like the power supply is all good. Now the big question is, what should we do? Should we hook it up to a monitor and just send it? Or should we take it all apart and inspect it first? I know it's already been connected to power and tested. I'd like to see what is wrong with the system. So let me just hook up a monitor, we'll have a look, and then we can tear down everything. All right, let's do that. All right, the monitor is all connected up, and I'm gonna flip the switch on the power strip, and we'll see what happens. Nothing's happening. Oh, yeah, whoops. I didn't reconnect the PSU to the motherboard. Stand by. Okay, the power supply is reconnected. Let's try that again. Take 2. All right, that's better. The power LED came on this time, and it didn't before. That's how I knew I had screwed something up. It's not doing anything. It should prompt us for a disk, but the drive isn't seeking. There's nothing on the screen. It's not even flashing any colors to indicate an error message. So we have something fundamentally wrong, and I guess it's time to tear down the Amiga 1000. All right, let's do it. But first, I found a copy of the service manual online, and it reminded me that I needed to check the power supply under load. So I reconnected everything up, powered on the machine, and tested all of the voltage rails again with the machine on, and it all tested out fine. The next thing it wants me to test is the video output here on R16, R23 through 25. So let's get the machine turned on and I'll do that. Now what we're expecting to see is about 5 volts on R16, which is the composite video sync signal. And if we look at the Vmax, we are seeing 5.28 volts, so that looks pretty good. The composite sync looks good. Now we're supposed to measure R23 through 25, and we should see 1 volt on each of the analog R, G, and B lines. And there we've got about 240 millivolts. On R24, we've got 240 millivolts. And on R25, we've got 240 millivolts. So we are not seeing the correct voltages on the R, G, and B, so we're not getting video output, even though we are getting correct composite sync. So there may be something wrong with the video subsystem, or there may be something wrong with the machine itself. But the funny thing is, in the service manual, it says if you fail this test, to replace the computer PCB. So it's saying stop, don't do any more troubleshooting or diagnostic, replace the whole computer. So we're not going to be doing that. We're going to dig in even further. I found another service bulletin online that mentions common symptoms and failures, and it says that if you have a black screen situation, that it could be the 8361 Agnes chip. And Agnes is responsible for addressing, DMA, blitter, copper, and even clock generation, so it certainly could be Agnes, but I'm guessing it could also be the 8362 Denise chip because Denise is responsible for graphics. So what I'm going to do is I'm going to pop both of these chips out, spray some contact cleaner in there, and just reseat them and see if that makes any difference. Now, I don't suspect these are going to be the problem because we're looking at a mechanical failure. Remember, this thing took a hit during shipping. So we're looking for something physically damaged, not something electrically damaged. But, you know, this certainly won't hurt anything. All right, let me flip the switch. Let's see what happens. I've got both RGB and composite hooked up, so I can switch back and forth just to see if either is working. But it doesn't look like any signals are being produced, so the machine is still good and dead. We'll need to tear the system down and really dive in. But first, how about a cleaning montage? For the purpose of repairing the plastic, I'm going to try something new today, and that's to use acetone to try and fuse the plastic back together instead of the regular super glue that I normally use, which adds extra material and has the potential to make a bit of a mess. So I'm going to try the acetone first, and if that doesn't work, then I'll fall back to the super glue. All right, here's the verdict. The acetone was fast and effective at rejoining the broken plastic pieces together, and as you can see, the seam is almost completely erased, but one side effect is that it did return the plastic to original whiter color than the yellowed plastic is now. So you can see where the repair was made. Although this is, 10 times better than it was before, I'm going to either have to clean this up and try a little bit of sun brighting to bring that whiteness back to the rest of the plastic so that it masks the repair a little bit. But all in all, yeah, that worked pretty well. And given how damaged this was originally, I am pretty happy with how it came out. I'm really pleased how this came back together, and it's starting to look really good, but there is some discoloration and a little bit of texture where the plastic was melted back together. So what I'm going to try and do is use some 400 grit sandpaper, and I'm just going to wet sand a little bit to remove some of that texture and some of that color. All right, done wet sanding, and yeah, it's completely smooth now, and it looks really great. One of the benefits of wet sanding is that it removes a small layer of the plastic, and it actually removed a lot of the yellowed plastic, and now we have just smooth, original color here. You can barely tell that this piece has been repaired now, so I'm really pleased with how that turned out. Good progress so far, but there's still lots left to be done. In the next episode, we'll continue to troubleshoot the board, 3D print some replacement parts, and try out this new vapor brighting method I've been hearing all about. Can we save this poor broken Amiga? Make sure you like and subscribe so you don't miss out on the exciting conclusion. I hope you enjoyed this bit. Thank you so much for watching, and we'll see you next time on Retro Bits.